Let us in this presentation discuss about the Elasticsearch queries. So first off, let us start the Elasticsearch server, and once the Elasticsearch server getting started, let us understand about the different types of Elasticsearch queries there. We already know that Elasticsearch provides a RESTful API interface to interact with it. So we can use any REST client software, maybe it is Postman or any other else, or the dedicatedly used for Elasticsearch is the Kibana console. Okay, so from there we will be writing queries and it will be interacted with Elasticsearch. If we write queries in Kibana, then it will get a number of suggestions there, and it will be very much convenient for us to write Elasticsearch queries. So Elasticsearch server is up, and now we need to start the Kibana. Okay, so once the Kibana console is up, we will write queries there. So let us run Kibana. Okay, here is the Kibana home page, but we need the development tool. So here it is management. Inside management we will get a dev tool. So we already created some index related named as booked and put some documents there also now, and tested some very simple queries here. So first of all, let us say a few things about the queries. There are two types of queries mainly. One is called the leaf queries. That is the ground level queries, such like this match, which we write and which directly interact with Elasticsearch. These are called leaf queries. Leaf in the sense, when it is a tree, the leaf nodes are the ground level nodes, after which there is no nodes are there. In that sense, they are called leaf queries. Okay, because here inside this query there is no nested queries possible. So this match queries, there are other queries like term queries, range queries. Okay, all of these are leaf queries, means there is no nested queries possible under those queries. So these are called leaf queries. And another query type of queries is the compound queries. So compound query means, compound query is nothing but it's the wrappers which helps to combine a number of leaf queries together. Sometimes when we write want to fetch some data in real life, we need to combine a number of queries. For example, we want to match this term, and also there is another field, suppose the number of copies. We want to fetch only those books which have number of copies greater than some value. When we need to satisfy multiple conditions, then we need to use those compound query constructs, by using which we will be able to combine a number of queries together. So now let us see some example one by one of them. So here is the very simple query construct. This is the match query, we call it, because we are using the match parameter here. I am calling it as parameter because we know Elasticsearch is called through API interface, that is the RESTful API interface, and this is the API endpoint, and we are not writing the host name here. Actually the host name was mentioned in the Kibana configuration file, that is the Elasticsearch, the particular host and the port number on which Elasticsearch is running, that is the API host and port. And this is the API endpoint. Endpoint is when we are doing any search operation, then the API endpoint, here the index name and then /_search, and we are passing a JSON data, this one, to this API. If we would have written this query in any other REST client, might be in Postman, then in the data section we will be writing this JSON, or you can pass this JSON data by reading from any file also, but here this is the syntax how we write the query in case of Kibana. Actually in the background it will just call an API with this API endpoint, and this particular JSON will be sent as data. That is why I am calling this match a parameter. That is query.match is a parameter. So this is the lift query match, and this under this is the parent level parameter, and under this there can be multiple fields, multiple options can be there. For example, here is the book name, that is the field name on which we are targeting the search. That is, book name must contain a term that is called time we are wanting to do. So this is how the query is done, and there are, if we run this query we will get the result here. Okay, we have got the hits here, total number of hits one item has matched, and here is the record, here is the details. Now the match query can be written differently like this. Instead of directly array, this is a very simple query. If we want to configure it, then we need to write it this way. That is the book name. I have written the book name here, then I will give some properties here. So here I will write the query means the time, I am writing this way, and after that I can give the operator, and it is by default. Suppose we want multiple term, we are writing here history. Okay, then it is the operator then comes into picture. This is AND operator, means a document must contain these two terms. So here if we run this again, then we see that history and time both exist in this document. That is why we are getting the result. And if this operator is changed as OR, then also it will be displayed in the result. Let's see here, because both of these terms are there, and even at least one term is there. Suppose I am writing here anything which does not exist here. Okay, I am writing it here science. This term does not present in this document, still I will be getting this result. But if it is AND operator, then this result will not come. Okay, the value becomes 0. So this is the way we can specify the operator here. So this is the very simple match queries. Okay, and inside match query there are options like fuzziness, etc. That is, you are seeing that suggestion is coming here. Fuzziness means here the fuzziness index here. Fuzziness means if you write any suppose here you are doing spelling mistake here, you have done. Okay, suppose history, you are writing this and I am writing gym history, then also we are going to get a result here. Okay, because these are the fuzziness index. In this range these errors are. Okay, if we do it this way, that is the error is too much, then it will not be able to suggest you. But if the error is up to a particular range, then it will, suppose like this, then it will provide you the result. This is because of fuzziness. If I make it 0, then it is not going to return you the result. Okay, if your fuzziness index is more, that is 2 or 3, then more fuzziness result will be displayed, because in that case might be that if the fuzziness index is very high, then you can get some irrelevant data as well. So you need to balance this value. Okay, suppose I am making it 1, that is the default one, then you will get this result. Okay, so the match query is the most used full text search query tool, you can say. The match query has another version that is called multi-match all. So this is a very simple match query where we are targeting only one field, that is the book name. Okay, now if our requirement is like this, suppose the input string is like this. time and Stephen. There is the terms are not present in one field. There is one particular term present in book name field and another term present in the author name fields. Then we need to write queries differently. Okay, so this, by using this match query, we can target only one field. So for such kind of queries where we want to target multiple fields, then we need to use the multi-match query. Okay, here, so we are going to write here query. Inside query we write the query name. There is the multi-match, and we already have got the properties here. There is the query. So here the query is the time Stephen. There is the terms are exist in multiple fields, and here I am going to write the field name. There is the book name. Okay, and if we run this query right now, I am going to get result, because by default it is the OR operator query. There is the only one field is getting matched with the book name, so that is why the result is appearing. So I am going to write the operator name here, operator AND. So now I am not going to get the result. So here I am saying that this is the array, because I am able to mention multiple fields name here. So I am going to author name also, because I want to target both book name and author name. Now if we run this query, still I am not going to get this result, because there is another properties we need to mention here, that is called type. Multi-match has a number of types there, and that is here by default is the best fields. So at this moment I am not going to discuss about this. Just write here the cross fields, means the fields might exist across the fields. Okay, now if we run this query, then I am going to get results, and this particular term time is matched with the book name, and the author name matched with the Stephen fields exist in the author name. So this way we are able to target multiple fields to get results. Also, multi-match queries has a number of applications there. By using multiple match, you can boost up the scores based on specifying the priority to the fields. By using the caret sign, you can give priority to different fields. That is, if particular term is matched with those prioritized, the boosted up fields, then it will contribute more score to the documents. So I am not going to discuss at this moment. Okay, we will discuss about this later. Now just let us discuss one by one the simplest lib queries one by one, and these are also useful in your practical life as well. Now one thing we have noted that till now, whatever the queries we have written, we are writing the entire keywords there. Users have written the part of the word and I want to show result, but here I am not going to get result. But if we want like this particular type of queries is useful when you want to show users suggestion while user is typing. Okay, that is the entire word is still not written, but if you want to suggest results, in that cases we need to use the query string query. Okay, let us see an example. Here we are writing the query construct by using query, and here the query name, that is the query string. So here you will get the default field. There is the field name, particular field name you are targeting, say book name, and here you will write the query here. Suppose user is typing history, HIST, he has written till up to this, and you want to show result to the user. If you run this, you are not going to get result at this moment. So first if you want to match part of the field, then you need to write it like an wildcard. Okay, so you need to use this star here, means hist star will match hist anything prefixed with hist, any term with prefixed with hist will be matched. So I have run this query and the result is there. It is matched with this history field. Okay, history keyword. Okay, sorry. Now this way you can mention multiple terms also, time star also, then you are going to get result here. If you want to target author name, then so the query needs to be changed here. So I'm writing stf and star, then I'm going to get result. Okay, this way the wildcard query, that is the query string query, works. One more thing to mention here, if we write, suppose this is the field name is book name, and here I have written east star and abc star. So abc star does not exist there, but still I'm going to get result because the default operator for this is OR. So I need to mention the default operator here. It is OR already, so I'm going to change it as AND. Okay, so if it is changed to AND, then I'm not going to get result now. So you need to remove this, then only we'll get results. Or you can type the TIM star, then you will get result, because both of this pattern exist here in this book name field. Now let us see another leaf query, that is the range query. Okay, till now whatever we have done, all of these are text search queries. Now we'll going to use the range query. Here we write the query, and after that the query name, that is the range, and then you give the field name, that is I am here using the number of copies field. And here there are two options we are seeing, there is the GTE, means greater than or equal to, and LTE means less than or equal to. Okay, less than, equal to, and greater than. You can remove the E as well, that means only greater than. Okay, and LT means only less than. So here if we run this query, so we are not going to get any results in this range. Now if we write GT 500 and less than 700, then I am going to get one result there, which have number of copies as 600. Okay, let's increase the range. So I am getting here three results, number of copies 1000, number of copies 600 and 700. Okay, this way. And also we can use the GTE or LTE query also. Suppose this is LSN and this is GTE I am using. Okay, 600 I am writing it here, so I am going to get the 600 result here. Okay, this way. And this is all about the range query. One thing to note here, that the score we are getting here also equal score, but earlier when we are doing the field full text search queries like this match queries or this query strings queries, then the scores was calculated differently, that is the 2.0 here, and if multiple items matched here, then the score will be generated accordingly. But in case of range query, it does not contribute to the score anything. Okay, these are the few example of the leaf queries. There are many more queries there. You will get it from the Elasticsearch website. Here you just search in Google the query DSL by using this keyword Elasticsearch query DSL, and you will be landed to this page. And here you will get a number of query options are there. There is a full text queries. We have seen the example of match queries, the multi-match queries, okay, the query string queries, and there are so many options are there. But from the examples we have given till now, you will be able to know that is how exactly the query is constructed and they are run. Okay, and by seeing this example, you will be able to see just by reading from here, you will get to know about how all of these types of queries are executed and what are their particular use cases are. Okay, and there are many other queries there. You just first learn the very basic queries, and after that you go to all of them one by one, though you do not need to learn all of them at first. If you learn only a few of these, there is the match query, match phrase query, multi-match query, and query string queries, you will be able to implement in your practical requirement. It will be satisfied. Now another thing, these are the examples of the leaf queries we have discussed. Now we will move to the compound queries. Okay, So here is the compound queries. About the compound queries, you will be able to see it from here. Mostly used is the boolean query. Okay, we are going to take some example of this and want to see how they work.